What if I told you we've just looked deeper into the universe's past than ever before, and what we found was a monster? Astronomers, using the James Webb Space Telescope, have confirmed the existence of the oldest, supermassive black hole ever discovered. Born only 500 million years after the Big Bang, it challenges everything we thought we knew about the early cosmos. How could something so massive form so quickly in such a young universe? And what does this discovery mean for our understanding of cosmic evolution? Stay with me, because today we'll journey across 13.3 billion years of light to witness a black hole that should not exist, but does. If you're fascinated by the deepest mysteries of space, hit like, tap subscribe, and ring the bell so you'll never miss a voyage into the unknown. The James Webb Space Telescope, or JWST, launched in late 2021, was designed for exactly this: to peer back the first billion years after the Big Bang. Unlike Hubble, which was powerful but limited in infrared vision, Webb's massive golden mirror and cutting-edge instruments are tuned to catch the faintest whispers of ancient light. Every time Webb stares deep into space, it's not just looking far, it's looking back. And this time, it found something extraordinary: a galaxy known as Kuiper's LRDZ9, a tiny, red smudge of light, turned out to host a supermassive black hole. Not just any black hole, but one weighing an estimated 300 million suns. Pause on that for a moment. A black hole this big, appearing so early in the cosmic timeline, should not exist, according to our current models. Let's put this into perspective. The Big Bang happened 13.8 billion years ago. The light we see from Kuiper's LRDZ9 began its journey 13.3 billion years ago. Back then, the universe was a chaotic infant, only about 3% of its current age. Stars were just beginning to ignite. Galaxies were small, clumpy, fragile. And yet, somehow, in the middle of this turbulent era, a black hole had already grown to hundreds of millions of solar masses. It's as if you discovered a fully grown oak tree in a forest that was planted just yesterday. Impossible, unless something about our story of cosmic growth is missing. You might wonder, how can astronomers possibly identify a black hole from so far back in time? The answer lies in spectroscopy, breaking light into its rainbow of wavelengths. When gas swirls around a black hole, it moves at incredible speeds. Light from gas falling toward us gets compressed, shifted to bluer wavelengths. Light from gas racing away stretches, shifted to redder wavelengths. This creates a unique fingerprint of motion in the spectrum, a signature that screams, "There's a black hole here." And that's exactly what Webb saw in Kuiper's LRDZ9, the smoking gun of a supermassive black hole, just 500 million years after the beginning of everything. But this discovery also unlocked another puzzle, the so-called little red dots. When Webb first began its observations, astronomers noticed strange galaxies, tiny, extremely compact, surprisingly bright, and glowing with a deep red hue. These galaxies didn't look like the ones Hubble had shown us. They seemed out of place, too bright, too red, too early. Now, Kuiper's LRDZ9 is one of them, and its brightness might not come from the stars at all. Instead, it could be powered by the blazing energy of a growing black hole, shrouded by a thick cocoon of gas. In other words, these little red dots might actually be black hole factories, lighting up the early universe in ways we're only now beginning to understand. Here's the big problem. To reach 300 million solar masses in just 500 million years, a black hole would need to grow at an astonishing rate. But according to our theories, black holes form from the collapse of massive stars, just a few tens of solar masses. So how did a tiny seed black hole balloon into a supermassive giant so quickly? Astronomers see two possible explanations. Number one, supercharged growth. Maybe early black holes were much hungrier than expected, swallowing matter at breakneck speeds. Number two, heavy seeds. Or perhaps the first black hole didn't start small at all. They might have formed directly from the collapse of enormous primordial gas clouds, already weighing tens of thousands of suns. Both scenarios challenge our current models. Both raise new questions about the nature of the early cosmos. Why does this matter? Because black holes aren't just monsters. They're architects of galaxies. The energy they release as they devour matter can shape star formation, regulate galaxy growth, even influence the chemistry of the universe. If supermassive black holes existed so early, they may have played a central role in sculpting the very first galaxies. In fact, galaxies and their central black holes may have co-evolved, growing together in a cosmic feedback loop. This discovery pushes that partnership back to a time when galaxies were still in their infancy. Another fascinating clue lies in Kuiper's LRDZ9's deep red color. That glow might come from thick gas clouds surrounding the black hole, filtering and reddening its light. Or it could be due to extreme distances, redshift stretching the light as the universe itself expands. Whatever the case, this galaxy looks nothing like our own Milky Way. It's tiny, turbulent, and dominated by a black hole that outweighs half its stars. A reminder that the early universe was not a gentle cradle, but a violent, fiery forge. For decades, astronomers believed supermassive black holes took billions of years to grow. But now, Webb is showing us that some may have started big or grown fast, far faster than we imagined possible. That means our cosmic timeline might need a rewrite. The early universe may have been far more efficient at building giants than our simulations suggest. And if that's true, it could explain why quasars, brilliant beacons powered by black holes, were already lighting up the skies less than 1 billion years after the Big Bang. This discovery is just the beginning. The Kuiper survey and Webb itself will continue hunting for more little red dots. Each one could hide another ancient black hole, waiting to tell its story. The more we find, the clearer the picture becomes. We may discover that the early universe was swarming with giant black holes, monsters born in the dark, shaping the first galaxies. Or we might uncover a new form of cosmic physics, something our current models can't yet explain. So here's what we know. A supermassive black hole, 300 million suns heavy, existed just 500 million years after the Big Bang. It lived inside a rare little red dot galaxy, glowing strangely bright and red. Its existence challenges everything we thought we knew about how fast black holes can grow. And here's what we don't know. Did it start from a massive seed? Did it grow impossibly fast? Or is there a third explanation? Something we haven't even considered yet? Whatever the answer, one thing is certain. The James Webb Space Telescope is rewriting cosmic history before our very eyes. And we are not just witnesses to the universe's past, we are students of its secrets. If you enjoyed this journey across billions of years, don't stop here. There are more mysteries waiting, hidden quasars, rogue galaxies, and black holes that defy imagination. Smash that like button if you learned something new. Subscribe to BackSpace for more mind-bending stories of the cosmos, and ring the bell so you'll always be the first to know when the universe surprises us again. Because out there, beyond the stars, the greatest discoveries are still waiting.